All right, so now the setup is I have a, it's called conjugate heat transfer. So I've got a hot plate that I'm going to heat up. So I've got this whole thing is providing 200 watts. I have an inlet mass flow of some fluid, a coolant fluid coming in. And it's also coming in at 5 degrees, so it's coming in cold. And then as it goes around the hot plate, then it's of course going to heat up, and we want to see what the outlet temperature is of this thing. So we're going to see how well both of these systems kind of run. The setup is the same on both. So let's go ahead and run it. I am going to go ahead and remesh. That way we're solving straight from scratch. So I'm going to get this guy up. Hit mesh. And we'll go ahead and hit the run about the same time. Ready? Go. Now, let's go ahead and first it's going to mesh. While we're doing this, I'm going to take a look at our processors. So the mesh is single cord. It's got to start the mesh and actually grow it. Once the mesh is grown, then we can come back in and we can start looking at creating iterations for the temperatures. So you can see it's starting to do iteration by iteration. On the S3, you can see it is a 6-cord system with hyper-threading. And the Intel Xeon over here on the Dell is a 4-core system that also has hyper-threading on it. So it looks like we actually have 8 cores here, and looks like we got 12 over there. So we can already see on the Apex 3 the heat coming into the tube, or actually it's coolant coming into the tube, and then it's getting warmer and warmer and coming out hot. And actually the solver's finished. We can look at some of the results here. CPU time, it took 35 seconds. And we did get convergence, so we're good. We're at a static state on flow. This one's still doing iteration until we get to a static state. So it looks like we got about 96 iterations here. We're almost done. Got about 10 more to go. And this one actually finished about 97 iterations, which is good. You can see this one took 1 minute, 3 seconds. So it doubled the amount of time. Of course, we did have a little bit better processors. And the speed was also considerably faster on the S3. So let's go ahead and take a look at some of the quick results. And we'll just do the results on this guy right here. So let's take a look at a cut plot. And I want to look at temperature. So you can kind of see where the heat plate is heating up, and it's heating up the air that's around it. We do have convection, so it's actually starting to come off of that top plate. So some really fun stuff. You can kind of see that we've got a quicker, faster machine over here with the S3 doing CFD, computational fluid dynamics, in SOLIDWORKS Flow. All right, so another way to test how good your computer is, so of course doing FEA analysis or simulation. So this came straight out of the training session for Simulation Professional. Just kind of a setup, and you can download these models directly from SOLIDWORKS if you want to. I have a fixture ran here to, those things can actually rotate about these axles. And then we also have a force vector on this. We've got 900 newtons going down and then 115 newtons going on a side load. And that's pretty much it. All the parts, materials are a little bit different, but they are the same for each of the setups. So here we go. Let's go ahead and start this guy up. So I'm just going to right click on it, hit run at the same time. So here we go, 3, 2, 1. And we'll let this guy run. Now while it's running, let me go ahead and move this up. I am running in large displacement mode, so it should take a little bit longer. And then I also have my task manager. Go ahead and start these guys up. And so, you know, again, notice it's at 3.7, but we're starting to max out on our speed at 4.7. Now, even though I'm not utilizing the entire part of the cores, the speed is faster. So kind of notice over here, it says it's 3.6, but we're running right about 3.5, somewhere around there. 3.3. So let's let this guy run. All right, so we're getting pretty close. Over here we got about 99%, so we'll let it go ahead and finish out. And again, you can kind of see that the speed here, we're about 4.77, about 3, 2.9, 3.3, 3.5. So just kind of jumping around a little bit, or we're kind of pretty much maxing out the speed on the CPU over here. So we got 100%, we're pretty much done. We can pretty much minimize that. I didn't have any problem with memory. I was running 3.6 gigs of memory. Here I'm at about 5. It will drop a little bit though after it completes the solution. But we can go ahead and get to work over here. So let's, we've got the stress analysis there. We can do a little animation, make sure I put my restraints and loads on there right. Looks pretty good. We can do some ISO clipping. So you can kind of see exactly where the flow lines of the stresses occur. And graphics are updating pretty quick. Pretty much as fast as I can move them. We can look at our displacement plot. Our strain. We can add some other features in here. I actually want to see the mesh. So here I can kind of see if I need to go in and remesh. Of course, if I remesh, I have to rerun. But that looks pretty good. And if I'm happy with the results, then I can go ahead and spit out a report. So let's go and add the designer. If I can spell my name right. There we go. And the company, GoEngineer. And let's go ahead and publish this. So it's going to create a Word doc. And I will tell you, on my old machine, sometimes this would take about a minute, minute and a half to complete. I can tell already it's going pretty fast. Alright, so I've finished my report. Kind of gives a little bit of overview. I get a little table of contents. So I pushed like 2 buttons. Here's some of my model information. Mass, properties, volume, density, all that good stuff. Some of my fixtures. Some of my properties that I set for my study. Units, material properties. So most of the parts were alloy steel. And then here's my fixtures and forces, my contacts. And then we'll go right on down to the results. If you want to know a little bit about the mesh, we were running at about, total elements was 34,000, and I have about 58,000 nodes. So there's the mesh. We'll go on down to my von Mises plot. And there's my max von Mises, and then displacement plot, and my strain. So I've got my report already done. I can go ahead and save this and start working on my next one. And it looks like the Dell is almost finished. So we're at 99%. So we're about 11 minutes, 45 seconds. I forget which one this one is, so let's go look at the results here. My solver messages, this took 7 minutes, 52 seconds. We're now at 12 minutes. So we should be getting pretty close. Once it's done actually solving, it's got to put all that information back on the hard drive, so it does take a while to copy all that. There we go. So it's looking pretty good. Again, I could run through my little animations and stuff. See how it looks, see how it works, see how it functions. And main thing, of course, is the results. How fast did it do it? So we're looking at 7:52 next to 12:17. So pretty good little test. All right, so another way to check a little bit more of how the processors help is by doing a flow analysis. So this is CFD inside of SOLIDWORKS. And kind of just for the setup, I've done this as an interior CFD analysis. I do have a rotating region. So kind of this little box is rotating at 200 radians per second. And then because I have the little fans in there, then the air is going to actually swoop up and start going in a different direction than just kind of rotating, spinning outward. So I'm going to go ahead and turn off the outside computational area there. And let's go ahead and run this guy. So I'm going to get these going at the same time. Let's get my little dialog box up. And I am going to have it remesh and solve. Again, we're using all cores. So here we go. 3, 2, 1, click. So I think I got those pretty close. So we'll go ahead and pull up our little solver. It's going to start up meshing. And while it's doing that, we'll also pull up our task manager so we can look at our CPUs and our speed. All right, and we can see the little iterations down here at the bottom. Looks like, not sure the total amount of iterations, but it is quite a few once it starts going. So let's let it run. You can kind of see here, the CFD analysis compared to the simulation really does max out the cores a lot more. The mesh, once it generates and grows, it's kind of more single core, but once we get the mesh, then we can utilize all the cores pretty much to their fullest extent. You can see here on the Xeon, we're actually starting to max out that 3.6. We're pretty much hanging on that. And on the i7s, we're running 4.77 consistently. All right, well, it looks like we're done over here on the BOXX machine. Solver's finished. CPU time was 19 minutes, 14 seconds, 3,600 iterations. So let's take a look at some of our results. You can kind of see where the CPU finally finished at the, kind of dropped everything. So we're looking good. And let's take a look at a cut plot real quick. So you can kind of see the flow and the vectors we can look at our flow trajectories. This is actually created with a sketch, and we can animate these. So you'll start to see the air coming in, and then as it comes in, it's going to go through the fan, start to spin, and give us some pretty cool little twisting going on there. And I like to change these up a little bit. Let me edit this. And we're going to put these in spheres. And in fact, let me add a couple more since I can. And we'll animate that. So you can actually see the flow of that going around that fan. And right now we're looking at a velocity curve. It's looking pretty cool. All right. And then we'll be right back when we're done with the Dell. We'll let that finish. All right, well, we're getting down to the wire on it. We'll go ahead and show some cool stuff while that's going on. So calculation time left on the Dell. We got about 4 more seconds left. We're just finishing up our 3,600 iterations. Looks like it's done. You can see our CPUs are going to drop off now, and our memory should drop just slightly. So as far as the total comparison, let's take a look at our results file, our little summary here. And we'll take a look over here on these guys. So final head count, physical CPU time. Right here was 2,128 seconds. And over here on the BOXX was 1,154 seconds. So quite a significant time frame. If you're doing any type of CFD analysis, then you know where to go there. So let's take a quick look on some of the rendering speeds that we can do with using SOLIDWORKS Visualize on both of these machines. So I have a live 3D model. You can see I can kind of rotate that guy around. And we'll take a look at some of the settings. So on both of these, on the 3D viewport, I am using GPU acceleration. So this is going to be more for the graphics card, but it still uses a little bit of the CPU as well. And let's go ahead and give it a nice little backdrop. So we'll put it in the desert sunset. And you can see kind of just working around, it's pretty quick, pretty fast, looks good. And I do have it on accurate. I am running on accurate on both of these things. So let's go ahead and get to some rendering. Now I've also at the same time gone ahead and put my little CPU out here so we can look at the task manager and kind of see what's cranking on that. We may also want to look at the GPU down here while that's cranking. For right now, we'll leave it on CPU. All right, so we're going to just output this to a JPEG file, and this will probably happen pretty quick. Both of these are fairly, actually quite fast systems. So we'll get these ready, set, go. So starting the render up. You can see the CPU really isn't doing too much there. So let's crank over to the GPU. And you can see these things are starting to crank up down here for the memory usage. And it looks like render's complete over here on the left and just finished over here on the right. So of course with the same graphics card, same driver, same everything, we should get pretty quick results. A little bit faster over here on the BOXX S3. So I want to thank you guys for joining me on this comparison between the Apex S3 by BOXX and the Dell Precision 7920. We had a good time comparing assemblies, drawing performance, simulation with the suspension, flow analysis, especially the flow analysis, and then some visualize at the end with some photorealistic rendering. So kind of to wrap it up, this is a $5,000 machine for the BOXX. The Dell Precision is about a $6,000 machine. It did have space for another processor, but that's another $1,200 in cost on that. So you got to kind of think about, I'm actually doing things that are right here today. If you have an old Dell that's about 3 years old, then you're losing out on quite a bit of productivity. If you look at that flow analysis, the BOXX finished in about 19 minutes, and this is a new Dell Precision workstation, and it was about 33, 34 minutes. And so that's quite a lot of productivity there. You can kind of take a look at our 3-year-old system for the BOXX, the 2403, and we were looking at, seconds and minutes compared to, 13, 14 minutes. That's a huge change, and that's a very big loss in productivity. So if you're going to ask me which one I'm going to pick, of course it's the BOXX.